I'm going to talk about right triangles now and how we find the trigonometric functions for special angles using right triangles. So this is my preferred way of doing it over the unit circle kind of, but unit circle is good. I love the unit circle too, but I'm going to talk about a 30-degree angle first. So say this angle here is 30 degrees. I have to remember one piece of information. First of all, our right angles are, that's not the piece of information. I have to remember that the sine of 30 degrees is 1/2. And so what I'm going to do is I'm going to make this a 1, and I'm going to make this a 2. Because then my ratio for sine, so sine 30 degrees, opposite over hypotenuse is 1/2. Okay, so that part's done. Now, I can find the third side by using the Pythagorean theorem. So I'm going to do that. See if I can move this over a little bit, because we don't really need as much room. So it's a right triangle, so I can use the Pythagorean theorem and say 1 squared plus, and I don't know this side over here, call it x squared equals 2 squared, the hypotenuse. So I get 1 plus x squared equals 4. I get x squared equals 3. So I get x equals the square root of 3. And then when I know all three sides of a right triangle, I can find all the ratios. So I can say the cosine of 30 degrees is adjacent over hypotenuse. And I can say tangent of 30 degrees is it's opposite over adjacent, so it's 1 over the square root of 3. But I have to rationalize that denominator, and so that's going to give me the square root of 3 over 3. And then I can do the reciprocals. So cosecant 30 degrees is going to be equal to 2. So just reciprocal of the 1/2. Secant 30 degrees is going to be 2 over the square root of 3, but then again I have to rationalize it. It's going to wind up being 2 times the square root of 3 over 3. That's kind of the messy one. And then the tangent, oh, sorry, we did tangent, cotangent, sorry. Cotangent 30 degrees is going to be the reciprocal. And if I take it before I rationalized it and reciprocal, it'll be easier. And that gives me then the square root of 3. So I can find all my trigonometric functions that way just by using the right triangle and opposite over adjacent and those ratios that we already talked about. Okay, now we're going to talk about the 60-degree angle. So 60 here. But if it's 60 degrees here, then, and I have to put the right triangle in, there's the right triangle. Then that means it's 30 degrees up here. And so it's the same triangle over there, it's just turned. So that I can make this the 1, this the 2, and this the square root of 3. And then I can go through by using, opposite over hypotenuse and all of those to do my trig functions. So sine of 60 degrees is going to be the square root of 3 over 2. Cosine of 60 degrees is going to be 1/2. And tangent is going to be the square root of 3. And you can see that the sine and cosine have switched places because those are co-functions. And when you have complementary angles, or co-functions are switched. So, okay, there's a thing on that. Okay. Cosecant, get the cosecant in here, of 60 degrees then is going to be 2 times the square root of 3 over 3. And the secant of 60 degrees is going to be 2. And then the cotangent of 60 degrees is going to be the square root of 3 over 3. So you can think about that more if you want to, but it's a way to find all those trig functions just by drawing the triangles out. And for me, I find that helpful at times. Okay, so we have one more special angle, and that's the 45-degree angle. There's a couple ways you could do this. Let's see, I'm going to make this a little bit smaller. Okay. Okay, so this is when we have a 45-degree angle. And if it's 45 degrees here, it's 45 degrees up here as well, because it's a right triangle. And that makes it an isosceles triangle, which means that these sides are equal to each other. And I'm going to make them measures of 2. No, I'm not. I'm going to make them square root 2. Now, you can label it that way. If you have trouble, you could make it x and make whatever measurement you want for the hypotenuse, and then you could run the Pythagorean theorem on that one as well. But if I make it this way, it makes it convenient. So sine of 45 degrees is going to be the square root of 2 over 2. This one's a little bit easier to remember because of the repetition, I think. The cosine of 45 is square root 2 over 2. And then the tangent, if you remember some of your identities, tangent, sine over cosine, that's just going to be 1. And then we're going to go with the reciprocals. So cosecant of 45 is going to be the square root of 2. And secant is going to be the square root of 2. And then cotangent of 45 is going to be 1. And if you want to see any of these, or if you have any questions, just email me. I can do more detail on these during our Zoom meetings if you want me to. Okay, there you go.